I'm sure you've heard of Boyle's law. Boyle's law states that pressure times volume, pressure 1 times volume 1, is equal to pressure 2 times volume 2. But how can you demonstrate this? How can you show this? Well, I can show you this real easily with one very dangerous experiment that you can try at home. So this experiment can cause choking, drowning, or if you live in California, even cancer. You get a water bottle and a ketchup packet. Now you'll notice that this ketchup packet floats, which seems a little off-putting at first because ketchup is denser than water. Shouldn't it sink down? No, because there's a little air bubble in the packet. It's not completely full. So it's floating now, but when I squeeze this water bottle, it sinks down to the bottom. Well, why is that? Think about this. When I squeeze this water bottle, what happens to it? The volume is going to decrease, which means that my pressure goes up. PV equals PV. As my volume decreases, that pressure has to increase. And that pressure has to go somewhere, right? But you might know from experience that liquids like water don't really like to gain pressure, to decrease volume. But gases, on the other hand, are rather willing to. So as I increase the pressure on here, my volume of water is going to decrease in here, in this ketchup packet. And based on the Archimedes principle, you might know that the buoyant force of an object is equal to the weight of the volume of water it displaces. So when I apply that pressure and that volume decreases, the buoyant force of that object is going to decrease to the point where it sinks down to the bottom. This also shows just simple buoyancy, where we can assume water has a density of 1 gram per centimeter cubed, and that ketchup packet normally has a density a little bit lower than that. So mass over volume equals density, right? So when I squeeze it, pressure is applied, that air bubble contracts, and the volume of that packet decreases, but the mass is staying the same. So as that mass stays the same, the volume decreases, that means my density goes down, or goes up rather. My ketchup packet goes down to the bottom because it becomes more dense than that water. So I thought this was a really cool experiment. I did notice a few issues with it, notably that, or not exactly issues, but perhaps just quirks, right? Sometimes I, for example, needed to use warm water. If I used cold water, it wouldn't work. But that actually demonstrates another property, that being the property of the ideal gas law. Because as its temperature, the ideal gas law states that pressure times volume is equal to moles times the constant R times temperature. And so as we decrease this temperature, well, moles and the constant R are going to stay the same. We're not losing any mass. We're not changing the constants because it's a constant. It can't change, right? But that temperature in cold water, it's lower. So that means my pressure times volume has to be lower. And the pressure can't really decrease. Well, rather it does, but my volume is going to have to decrease. So it's going to sink down in colder water. It's going to be smaller, denser. It's going to sink down if I'm in a colder environment. But if I use warm water, that obviously has to be the opposite effect. That volume increases a little bit, and it floats. Now, you might run into problems with it still. You're using warm water, and it's still sinking. Well, what do you do then? Well, you can add salt water, or add salt to your water to make a mixture of salt water, which is a bit more dense than fresh water or clean water, which will increase the mass of, based on that Archimedes principle, it'll increase the mass of the water per volume, and as we have the same volume but more mass per volume, that means our buoyant force goes up, and it floats easier in salt water. So anyways, I just thought this was a really cool experiment, and I wanted to demonstrate that. Thank you.